Thank you today for coming to our webinar. Today, we're going to be seeing an intro to BoxLang AI, very dear project, and a lot of work for the last year and a half on this. So very excited to be doing our first webinar on BoxLang AI. For those that don't know, my name is Luis Majano. I'm a computer engineer by trade. I was born in beautiful El Salvador. I was raised in the US pretty much all my life. 2023, I'm leading the EU expansion here from Spain. I'm the creator and maintainer of several open source projects like Coldbox, SBox, and more. And now also I'm one of the creators and language engineers behind the BoxLang programming language. Before we start, a few announcements and a few goodies that you guys are going to get by attending this webinar. First thing is our developer conference is just around the corner, April 29th and May 1st. The majority of our schedule is out now, which is really, really compelling. Just go to intothebox.org. We've made it really, really affordable this year. 99 bucks gets you in. Tons of stuff for you to see and for you to learn. So please head out to intothebox.org. As well, we want to thank always our patrons by allowing us to receive your precious donations. We can continue to create tons of cool stuff as well. So thank you very much to all of our sponsors and patrons. As well, by registering for this webinar, attendees are going to get a nice little discount code. So just expect it in your email and you can use it for anything with us as well. All the stuff that I'm going to be showing on today is available in two websites. It's on the ai.boxlang.io that we launched a few weeks ago. And we also launched ai.orchestrations.com. So apart from all the open source goodness that you will get with the library, you have tons of services and tons of professional support that we can give you through ai.orchestrations.com. Two more announcements. Our Pioneer program for BoxLang is still active. So if you want to do a migration or actually get a nice license agreement with us, just contact us and we'll make it happen. And our last announcement, Mr. Jacob Beers is going to be doing a free webinar on WebSockets, real-time web communications with BoxLang, Command Box, and the whole shebang. So this is on March 20th at 11 a.m. Central Time. So please register. That will be our next webinar. All right. Announcements are out of the way. What are we going to be seeing today for the next hour? All right, we're going to have two phases. Phase one is going to be AI concepts. I think it's really important for those that are new to AI. It'll be actually interesting if you're new to all this craziness. Just put it in the chat. I'll be checking in a little bit. But we're going to discover a little bit of the AI concepts. I'm not going to go very deep, but I think enough for anybody to start getting dangerous. In phase two, we're going to discuss what is BoxLang AI, some of its key features, and we're going to do a lot of coding. All right, phase one, AI concepts. Let's start with the big one, of course. What is AI, artificial intelligence? Artificial intelligence is definitely a field of study on systems that simulate human intelligence. This is an entire field of study, just like saying physics. And within this field of study, there's many things going on. So if we go deeper, we're going to talk a little bit about machine learning. And this has been going on for many years as well. Okay, actually, the field of study of AI exists since the 70s. And machine learning is basically computers how learn patterns from different types of data. Lots and lots of data. Some of this data is going to be labeled, which means that we're going to attach some type of identifier to that data. And some of that data is also going to be unlabeled. Okay? It's just like random data, or not even random, but just data that doesn't have any type of labeled metrics. And the whole point of machine learning is to discover patterns and to make predictions. That's the whole point about machine learning. Again, we're going to delve deeper into machine learning and what has become deep learning. And deep learning is when all these big guys are basically creating all these amazing neural networks to try to simulate how to train different models, just like the brain does, right? This is an inspiration of how the brain works to mimic it, right? And this is where all kinds of things come, like image recognition, voice recognition, how do we turn speech into a text or text to speech, right? Et cetera, et cetera. There's many different things around deep learning, such as computer vision, natural language processing, robotics. And then, of course, we get into the big guns, which has been all the craze. It's generative AI, right? And here's where you're going to find your large language models, where you're going to find things like image manipulation and creation, music, video, et cetera. So this is basically how, if you want to digest AI, we go from the field of study into machine learning, into deep learning, into generative AI, and all the different components. And we're going to be talking a little bit mostly about Gen AI in this session. So if we look at Gen AI, a large language model basically is a massive amount of data that a model has been trained on. Okay, massive computational power in order to understand that type of language, right? And at the end of the day, is understanding patterns, right? It gives you the ability to have inputs and do predictions, right? And of course, this is going to create a lot of not only textual generation, but we get into audio and video and all kinds of things later on nowadays as well. But this is the concept of a large language model, is that we're going to have some type of input, and this language model is going to be smart enough to detect that input and predict what we want. Now, there are many, many LLMs now. I remember when there were three, but now there's so many, from OpenAI to Claude to Gemini to Grok to even Google, DeepSeek, right? Perplexity, OpenRouter, you name it. There are tons of options out there. And I think as we started to delve into introduction of LLMs, we start to see a lot of issues and problems that hopefully BoxLang AI will showcase how to solve. All right, concept of LLMs. Where do we move next? Well, we talked that LLMs work on text, right? So let's discuss what are tokens, okay? So this is important. Tokens and token economy. LLMs don't read words, right? They're going to read tokens. They vectorize everything, right, in order to do mathematical computations to figure out these patterns. So one token is equal to 4 characters. Important to remember this. Why it matters? Because it is your billing unit. This is how you are going to get billed, okay, if you're using some of these large language models that are in the cloud, right? So they takes your words, creates tokens out of them, and that's your billing unit, okay? So it also defines performance. So the more tokens, less performance. And remember, it's all about generating content. So we move on that these tokens create what's called a context. And you're going to see this a lot in many of your tools. Okay. And the context is really composed of all the input plus all the output of those tokens create the context. This is like your working RAM. This is what the LLM has to work with in order to predict and create, right? Usually, this is referred to as the context window, okay? And the context window has a size, okay? When it reaches a maximum, things are pushed out, right? And new words and new textual input comes in, okay? And each LLM has different windows, okay? So if that tokens exceed that limit, truncation happens. Remember that. So if we go to context window, I put a little chart here. It might be not up to date because these things change so fast, but you can see that here are the 4 major ones: OpenAI, Grok, Anthropic, and Google Gemini. And you can see the amount of tokens that they can manage at one point. I think Gemini is leading the charge with 1 million, probably more now. We go to the next topic, which is really, really important, which is called something called context rot. And this is what happens when you start working with a certain prompt and you continue to iterate, okay? And what starts happening is that the older information starts to get lost, okay? All that information is now going to be ignored by the LLM and buried in tons of memory and long prompts, okay? It's really up to the application that you're using, whether it's Claude Code or Open Code or whatever, to actually kind of keep track of those contexts, right? But this is where the term summarization is going to be included now. Summarization is really required, right, in order to keep things fresh, but things can always be lost. And this is where things can happen, like the AI can hallucinate, right, because things are already forgotten, right? And by hallucination, I mean that the AI is just going to create and invent things. There's also a parameter for all these models, which is called the temperature. And the higher the temperature, the more creative it can be. Or remember, it was lower or higher. I can't remember, but it's on the docs. But you can also control that type of creativity that an LLM is provided with that temperature as well. So, but remember this, context rot is basically when you have too much in your context, you're sending too much into these providers, and you end up basically with losing information. So you got to be careful about those things. And now pretty much every tool out there tells you if you're reaching those limits. All right. The next step is prompting, right? So obviously we need to have inputs. So it's important to have inputs. So if you look at the basics, right, we have to send some type of input to the model. And it's really all about the prompt. Okay. A really bad prompt is not going to create very nice things. So you have to be very, very specific. Okay. So this is where we get into structured instructions, right? We want to make things in points. How do we control that context? And we want the LLMs to break down tasks. This is really important. If it breaks down tasks, you have a higher chance that it would do what you want. Okay? So Let's look at a little bit deeper into this prompt engineering, usually referred to as prompt engineering. I grabbed the main concepts that made sense to me. Structure and instruction design. This is important. You want to craft clear, precise queries towards a desired output. You have to be very specific. If not, you're giving the LLMs very big leeway of creativity to do things. And this is how you can reduce those hallucinations. All right, role prompting also, it's important, right? There's also a specific personas that are assigned to the different messages that are going to be going in and out. Context shaping, and this is important. This is basically when we can start doing injection of different types of context inside of your messages so the LLM can be informed of real-time activity, maybe RAG, augmentation, right? Vector searches, etc. Okay, so that's where context shaping comes in. There's also output control, right? We can actually tell the LLM that we want the output in specific formats, right? We can actually pass in a schema or a different shaping of the responses. And usually what this is referred to as chain of thought, and tons of AI courses that you will find out there. It's basically just the idea that you want your models to show their step process. And this is important because, first of all, it helps with your context and really improves the accuracy and lowers hallucination. You'll see that the majority of the tools right now have a plan option. I really encourage you to start with planning mode so you can actually work on your context and come up with a nice plan instead of going into building mode and just not dealing with those steps and chain of thought. So always, if you're doing something big, go with the plans. Okay, multimodality. We talked about not only do we have text, but we're going to be dealing nowadays with images, with audio, with video, with music, etc. So important that text is not only the things that we work on. That's usually referred to as multimodality. Another word that you're going to start seeing, a buzzword that you see left and right being thrown everywhere, is RAG. And for me, I always think of a dirty rag. But it's not a dirty rag. It's basically retrieval augmented generation. And all it means, it basically gives AI access to relevant, up-to-date information. The LLM has been trained, like I said, on massive amounts of information, but it doesn't know real-time information. So somebody has to provide it. And this is basically a way that you can actually query a knowledge base. And this can be through traditional searches or what's called vector searches, which are mathematical computational search. Tons of databases out there that support vector searches as well, usually creating array embeddings for your data. And this augments the original prompt or your original query or question with that relevant data. And so imagine if you have a sales bot and you basically need to be able to do a search for PDF documents, and you need to be able to inject that information in so the LLM can process it. This is where RAG would come into place. So before you send things to the LLM, that's where RAG comes in. You get that information up to date, you inject it into your context questions, and boom, you send it back. And now the LLM can process everything factually. I love pictures. I'm a picture kind of guy. So I love this image. I can't remember where it was, but I need to put the reference later on. But just to follow it, like I mentioned again, we start with a query that you want to do into the LLM. But before we do that, we're going to have some type of retrieval. And this can be through another agent, actually, or it can be through your function calls. And this basically can go to different vector search engines, get information, create any kind of tooling, come back with that information, send it finally to that language model, and get your response. So that's when you hear RAG, that's all it's doing. It's augmenting basically your query so it can have real-time information. And then we get into memory. So the LLMs have no state. They have no persistence, okay? They only take input and they predict. That's it. So every request is really a blank slate, right? So memory, also important, is not the same as history, okay? This is something that you must implement. Okay, so you have to be able to send that conversation history back and forth, okay, to the LLM so it can actually distinguish the things. And that's where the context is getting bigger and bigger and bigger and bigger. Okay, so there's also the concepts of short-term memory, right, and long-term memory, right? You can see nowadays that OpenAI and Claude have this concept of memory that when you enable it, right, you have long-term memory, right? You even have the ability to actually go into different chats and get information about different chats. Again, another type of augmentation through that memory, okay? And that memory is stored somewhere. It's really up to you where do you store it, whether it's a long-term memory and it goes into a vector search, or it goes into a normal traditional RDBMS, etc. The majority of these chat engines that you see out there, ChatGPT, Claude, Gemini, etc., do this implementation for you. Let's talk about tools. And as developers, this is the area where we shine. So Tooling is basically just the idea and the concept that the LLM would do function calls for you. And this is basically another type of augmentation, right? You make a request to the LLM detects that there's a function call, so the LLM returns a response back to the caller and says, hey, you need to call a function because I need that real-time data. And then your code will basically call a function, which can be search an MCP server, retrieve an order, read files, stop a server, start a server, execute SQL, etc. Once you execute that function call, you get the results, you send it back into the LLM for processing. That's pretty much all it does. Okay. So the concept of tools is very, very important when you start creating your own agents. And that's where we get into agents. Okay. So what are agents? We hear them everywhere. We hear them actually too much, right? Everything's an agent. So agents are autonomous. It's really just an autonomous control loop, okay, that orchestrates a bunch of all the stuff that we've discussed. That's basically its job. Its job is to be able to look at all the different components and say, hey, I have different types of memory. I have different vector databases. I have different tools. I can even have sub agents. I can have large language models that I can talk to because I can have more. I can do augmentation if I need to, et cetera, et cetera. So your AI agent becomes a huge orchestrator, right? And you configure it. And then it's up to you to basically to tell it what to do in that specific control loop. And of course, there's many different flows that your agent can go through. And that's the cool thing, right? There could be a retrieval augment, a generation flow, right? There could be something that is just doing function calls. There could be something that's doing multimodality. How do you deal with audio? How do you deal with images? How do you deal with PDFs? So your agent is smart enough in order to, within that control loop, to determine what to do. And this is where we start really getting into, as developers, how can we create business solutions for our customers, right? Maybe we want to create a document automation. Maybe we want to do a chatbot for support or for hospital, right? How do we optimize processes, et cetera? So this is where the business solutions come, is when these agents can organize and orchestrate a solution. The next big concept is MCP, and we hear it all the time. Nowadays, it's not actually that old. It's very, Anthropic is the ones that created it, is the concept of a model context protocol. And all it is basically the concept that an AI assistant or a host is going to call an MCP server with a specific request, and it's going to get a specific response. Now, the MCP server is going to expose three things: tools, resources, and prompts. Okay, those are the three things right now the model context protocol exposes. Now, how do we expose it? Well, there's two protocols within the model context protocol. You can do it via HTTP or HTTPS or standard I/O. And standard I/O is basically just a pipe within an operating system. It doesn't go out through the internet. It's basically localized. Those are the two types of protocols that you can talk to a MCP server. All right, we've seen a lot of concepts. I'll go through some questions and before we dig into BoxLang AI, but of course, there are problems with AI, believe it or not. And the problems are that integrating AI can be very complex. This is the truth. It's an ever-changing field right now. Everybody wants to get ahead, and they're introducing all kinds of features and functionalities, and it's very difficult to keep up. And as you've seen, it's not only about making one API call, right, to a language model and say, that's it, right? No, there's tons of things involved into here if we actually want to build solutions with AI, okay? If you just want to use it for chat and give you advice, you're good. But what we want is basically to create intelligent solutions for our business. So we have to do all things. We have to deal with memory. We have to deal with RAG. How do we do search? How do we build agents? Or how do we build autonomy? How do we create these tools? And how do we make HTTP calls on MCP servers? How do we deal with the different capabilities that the large language models are introducing every day? How do we deal with the ever-changing APIs, the tooling and the different integrations? All these are problems, right? And this is where we thought that we could come in. And we said, okay, we now have the BoxLang language, which all these capabilities to give us a dynamic approach. You don't have to use Python or TypeScript. We can use BoxLang. And thus, the creation of BoxLang AI came about. So this is not part of the language. This is a complete module, right? We really wanted to bring separation here. One thing is a language, and another thing are the framework modules. And BoxLang AI is a framework for BoxLang. So before we go into phase two, so let's start with phase two. So the main reason around BoxLang AI was to bring a lot of this chaos into control, right? How do we deal with multimodal orchestration with augmentations in one stack. And this was the concept of BoxLang AI. How do we bring sanity? How do we make things easy? How do you make you productive to start working with AI, right? Obviously, there's a lot of difficult concepts, right? How do we abstract them? How do we break them down so developers can start creating solutions easily? And that's what we believe is what we have done with BoxLang AI. So we'll start going through some of the things that we've done with it and then discover it very, very intimately. It is a module, like I mentioned before, it's BXAI. It is a complete library that augments the language. It works for any other runtimes. It provides a unified LLM provider for over 14 large language models and routers. So you can do chats, embeddings, and multimodality, and more coming soon. Memory and RAG capabilities. We've created already access to be able to create memory and inject memory for over 20 different approaches. And we'll go through some of them. Document loaders. This is important. How do we actually get information into our vector databases? So we've created a set of document loaders, and not only for vector databases, but you can use the document loaders for anything. We really wanted this to be fluent. We've created a lot of frameworks for many years now. We want to make sure that the code that we create is also readable. That was very important. It gave you the ability also to create autonomous agents. Important. We saw that. It's the main shebang here, right? We want to be able to create agents. Dynamic tooling. How do we support tooling support? How do we create MCP servers? How do we invoke MCP servers? And much more. You can find out our website at ai.boxlang.io. And of course, it is fully documented. Please bear with us. There's a lot of documentation here. It's still in flux as we're trying to organize it in the best possible way. But there is a lot of documentation. There's also an MCP server available for that documentation. Important. This way you can actually add it to your coding tools and you can get real-time information about how to integrate with BoxLang AI. We've created a bootcamp course as well. Bear with us. We haven't announced it yet because it's still in flux, but it's there. We have over 50 AI examples plus over 20 that I'm going to be showing today online as well. And you can also check out all of our test harnesses. We are a huge proponents of TDD and BDD, and we have over 700 tests just for our library alone. So let's discover 5 key features, and then we'll go through all the source code and tell you where you can start playing around with BoxLang AI. Important, we mentioned the BoxLang providers. Pretty much every provider that you see here is supported. What would I say? I've used the majority of them. Some are good for some things, some are good for others. I've tried to explain that in the docs of what I use them for. There's some that are very specific, like for example, Voyage is very specific to just embeddings. So you can actually transform text into array computations. But I love Open Router and I love Hugging Face, and mostly because they're routers. So I can actually connect to any large language model behind those routes. So I love that. And then Doc Kane, which is amazing dude, collaborated Amazon Bedrock and Docker AI models, which I never knew about. So Docker actually has the capability to run models on Docker desktop, and you can connect to them and have a private local model. So that one's really, really cool. And I want to make another webinar just on how to actually create air-gapped and private providers. Multi-memory, also very important. A lot of capabilities here. So we support many vector databases. We actually created our own called BoxVector. And BoxVector was created mostly for mocking and the ability to test very, very easily in a development tier. It is a full vector database that is localized in memory. Chroma, hybrid, which allows you to basically have a vector and a normal memory in one shot. Okay. Pinecone, Postgres, MySQL 9+, Milvus, Quadrant, OpenSearch, also by Doug Kane. Thank you, Doug. And Weaviate. If you have more, we have an interface and we can add as many as we want. And then standard memories, okay, what are not vectorized, we created a window one, which basically keeps the most recent X amount of conversations. A summarizer, so it'll keep a certain amount of messages and then it will auto summarize. Session based, so this is if you just want to store messages for users in a user session, boom, there you go. We can store them in files as well. We can actually use the BoxLang cache, which is really important because this opens the door to all of the BoxLang Plus databases. So we have a Couchbase, a Redis, Mongo, and more coming. And this allows you basically to use vector searches and traditional searches with cache. And then, of course, we also have a JDBC, so you can use pretty much any database as a memory, including SQLite. All right, document loaders. We've created different document loaders and auto chunking. This was something very, very important I wanted to add, is the ability not only to load these documents, but we need to chunk them into different types of tokens to send them into these vector databases. So all that is abstracted to you. You just basically choose a size and it'll do everything for you. You can get things from normal text files, Markdown, PDF, CSV, JSON, XML. We've also created an HTTP, so it'll actually try to hit an HTTP endpoint, grab the results, and create a document load out of it. We created our own web crawler as well. Very simple web crawler, but it's there. RSS and Atom feeds. So imagine if you actually wanted to load an entire RSS feed from your blog and have that up for augmentation. You can very easily. System sources, you can say, here's a directory, go scan for every single file source. Or you can say, here's a database, go scan it. Lots of options. Event-driven AI. This was something that has made, I would say, Callbox the framework that it is because of interceptions and events. And we did the same with BoxLang, and we did the same now with BoxLang AI. There are tons of events that are being emitted in different life cycles of the AI communications. When a tool is registered, when a tool is called, when an agent is created, when an agent is being called, etc. And the idea is that we're going to be offering a lot of observation, validation, and analyzation, there you go, for BoxLang AI in our Plus modules. So we're going to have complete dashboards so you can see all your MCP servers, their performance, how they're doing, error rates, etc. So there's tons of things that's coming because of event-driven AI. MCPs was another very important area that we wanted to introduce very easily to developers. So we have the capability to create as many MCP servers as you want in your application. There's always going to be a default one, but you can create as many as you see fit. But you can also do invocations. So we've created a new way to actually invoke MCPs right into the actual BoxLang AI. So you can target any MCP and then basically invoke it. And of course, our BoxLang AI agents to give you all this orchestration. So we've added that capability to have that reasoning loop for input and responses. We've given you the ability to have multi-memory. So not only one memory, but multi-memory, and the ability to have tools and sub-agents and be able to organize and orchestrate with different large language models. So BoxLang AI agents is really a great orchestrating tool, and you'll see how easy it is to put one together. And of course, memories can be traditional or vector. All right, how do we start? Installation is very, very easy. You choose what you're going to be creating. I'm going to be working on the BoxLang operating system today. So just a traditional operating system because it makes it easier. But you can also use this for a command box server, a mini server, Lambdas, desktop apps, which are coming, by the way, pretty soon here. And I'll show you how you do, but we use either command box or use our binaries that we give you when installing BoxLang. Logging and events, important. There's a dedicated AI log, important. So you'll find that in your logs, anything that's available there so you can debug. You can also turn on request and response logging, either globally or per request, and I'll show you how to do that. And you can even register interceptors for observability. Once you have installed BoxLang and BoxLang AI, you can go to your providers of choice and you need API keys. So you can register those API keys with BoxLang in many capacities. You can actually create an env file and BoxLang will automatically read it or command box. You can add them to your shell source if you're doing this at the operating system. You can add them to your BoxLang.json if you wanted to. Of course, you can add them in code, but obviously not recommended. Okay, so I have a bunch of stuff in my demo that I use Gemini and OpenAI and Claude and OpenRouter. So you'll see that in those demos. So it's time to code. So let's move on to our coding here. And we'll start off, first step, what do you do, right? So important is if you go to boxlang.orchestbox.com, you'll see on the left-hand side where it says installation. And I'll show you two approaches. You can do a BoxLang quick installer or a BVM. And we are working on a VBM for Windows. So this is coming, it will be soon. But BVM basically just allows you to work with multiple versions of BoxLang at the operating system level. At the operating system level. Remember, BoxLang is multi-runtime. Not only you don't have a web server anymore. You can if you wanted to, right? But the BVM basically allows you to list how many versions of BoxLang you have at the operating system and then use and change. So here I'm using the current version, for example. If I actually wanted to install the snapshot version that probably was done before I made this event, you do install snapshot, force it, and basically it'll install BoxLang and the BoxLang mini server on my system. Remember, operating system. This is just pure operating system BoxLang. Now I can basically say BoxLang use, and I can say snapshot, right? And that will change to the snapshot. Maybe there is a bug on that one. I said BoxLang, not BVM. BVM use, right? And then I would say I want to use the snapshot version, right? And now it uses the snapshot version, right? I can change again and say current, or I forgot which one it was. BVM use latest, right? And now it's using the latest. Okay. So I recommend BVM. Like I said, it's coming to Windows as well. There's also a quick installer, which is global. Okay. And it gives you all these capabilities at the terminal level, but there's also a Windows installer as well. So we got you covered. You're going to choose your points, right? Here is the repo I'm working on, and I'll put it on the chat as well. This is available for everybody. Okay. And I put all the instructions there, everything that we can follow through. And I'm going to start going through some of these examples. Now, I have VS Code here open, and I have here the repo. I have an env file. I don't have any secrets here because I have them secret somewhere else. But the only thing that I have on my env right now is the BoxLang configuration. And this is important because I want to be able to manipulate the BoxLang configuration for this application. So when I run BoxLang at this level, right, it's going to read this BoxLang.json. And let's look at that. This is the most important part, is configuring the module for BXAI. So you can see here modules, BXAI, and here are the settings. So you can see that my provider, my default provider, is going to be Open Router. If you haven't heard about Open Router, I really recommend it. I have an account on it, and you can basically sign up and you can choose all the different models and create different routes to those models. Really recommend it. I've been very happy with it. And you can see that the default params that I'm going to use for that provider is going to be that I'm going to use the free LLM. Might not be the fastest in the world, but hey, it's free. You can change here as you see fit. You also have the capability to choose the default memory. So here you can see that the default memory is a window memory with the basics and the defaults. I can also create different permutations for my providers. Here's where basically I can define that whenever I use OpenAI, because remember, we can orchestrate with different models, and that's what we want, right? We are not going to be using just one model. I can say, whenever I use OpenAI, make sure that you use 3.5 Turbo. Okay, I'm using that because it's fast and cheap. Here's Claude. I want to use Sonnet 4.5. Okay, this is going to be a more expensive one, but maybe I want to do some coding here. The default timeout. You can choose your default timeout for the AI requests. And here's important. You can log the request to the AI log, and you can log requests to the console, log the responses to the AI log or to the console. Really helpful, especially when you're doing with all these types of API calls. Really recommend you turn these on. Be careful with responses, because there might come with some API keys or stuff like that. So be careful. And then the return format, this is basically the default. The default is single. If you wanted to do raw, then you can get everything that the LLM gives you in raw format. But remember, we're encapsulating here, trying to make things easy. All right, so that's the first step. Is I have an environment. BoxLang automatically basically uses it. It will leverage that BoxLang config. And what I've done is that I installed BoxLang AI locally. Okay, so you can see here that I ran BoxLang locally. And to show you how easy it is, I'm going to create a little folder here called temp. I'm going to go in it, and it's empty. You can see right here, it's empty. And if I wanted to install BoxLang AI locally, just for this folder, so this CLI application, I can say install BXAI -- local. And what that will do is it's going to install a BoxLang _ modules, and it's going to install basically BXAI within it. So that means that this module is only going to be for this CLI application. If I wanted to install it globally, then of course you remove the local, and now it's installed for my entire operating system. Many capabilities, that's more of a BoxLang kind of deal, but I just want to show you that that's what we've done here, is that you can have that there. Remember, we're not in a web app here. So it's right here. It's installed. I have nothing to do there. I have a mini server defined because we're going to be doing a little bit of web apps here as well later, and the README. Okay. You'll see also this strange little file called BVMRC. And this is basically, thanks to BVM, I can actually seed my CLI application to use this specific version of increase editor font. There we go. Maybe that's better. So I know that this application, even when you clone this, it's going to be pinned to this version of BoxLang. Okay. All right, let's start. Let's look at our examples. Tons of examples to go through. Let's start with the basic chat. Okay. So here's our basic chat. What are we going to do in our basic chat? Well, we're just going to say AI chat, what is ColdBox, and print the results. It's that easy. That's how we integrate with the default provider and the default model. So I'm going to run this example. So I can say BoxLang examples 01 basic chat. And just by running this basically is going to check my environment variable, do my environment variables, my config, execute this basic chat. So it went out. Obviously, I'm not getting any feedback right now. And it's going to go to open router and it's going to basically say, hey, what is ColdBox? And then it's going to come back and print my results. And as you'll see, it's going to take its sweet time. Like I said, I'm using the free tier, so it might not be the fastest in the world. But there you go. It came back and let's look at it a little bit bigger. It says ColdBox is an open source web application framework, key points, and there you go. So that's how easy I can start working with any large language model. That's it. I can just leverage the BIF called AI chat. So in order for you to integrate with any of those AI capabilities, your main entry point can either be a creation of a class or it can be a BIF. And all those are obviously documented here on BoxLang AI. You see that there are tons of documentation here. There's also references, but you can see here the built-in functions. So tons of built-in functions that you have available for you to integrate, and as well as the creation of different samples. So this is the first adventure, AI chat. So let's do some debugging because we don't want to be waiting. I want to see what's going on. So I'm going to go to the boxlang.json and I'm going to say log request to console equals true. Okay, so I want to make sure that I log that request is coming because it might be bad formations, etc. Right? I want to make sure that it does it correctly. So if I do this now, you'll see that now it detected my configuration change. And you'll see that it says, hey, there's an AI request going out at this time. The provider is Open Router. The model that it's using is the free one. Here's the endpoint that I'm going to use. There's a timeout. How many messages have I done already? And what am I sending? Well, this is the message that I'm sending. And then it's going to basically come back and give me my results and present them to me. Okay. And there it is. Okay. There's the presentation. So that's how easy we can start chatting with any LLM. Basic chat. That's it. Right. Now, remember, the AI chat BIF has tons of other different types of arguments, okay? And we can discover them in the references as well. So example one, done. Let's move on and make it a little bit more complex. So now I can say, hey, I want to create a custom provider and use the default model. So I'm still going to use AI chat. I'm still going to basically say what is ColdBox. But in my case, I'm going to pass the third argument. And granted, these are positionals. I can do named arguments and it'll look a little bit nicer. But choose your poison. I can see that the AI chat, I'll make a note here, receives 3 arguments. The first one will be the messages that I'm sending. The second one will be the params that I'm going to be sending into the model. And then the third one are the options. So params are basically things that are going to be sent into the large language model. And the options are specific to BoxLang AI. So in this case, I'm switching providers and I'm saying, hey, instead of using the default one, use Claude. Okay. And it will go to the config and they'll say, okay, where's Claude? Here's Claude. Here are default parameters. You can also add options here. Okay. So you have that capability and it'll print out the results. And then if I go down here, it says, okay, now what I'm going to do is I'm going to use Claude with a specific model. Okay. These are the params. And then I'm going to print the results, right? So we're going to leave that running and we're going to say BoxLang examples 02, and it's going to run. There you see my requests going out and we're going to start seeing those results. So very easily now with this AI chat, I can start talking to different models. And here you go. It gave me a different answer, as you see, for when I used the Claude Sonnet, that when I used the other one as well, right here. So all within that AI chat, I can start adding diversity and targeting specific models and specific providers. Let's go and see a little bit more fun stuff, right? Let's look at our options. So here it is, the same thing, but it's going to do the log request to the console. Well, I did it globally, but I can do it at this request only. So imagine you turn it off everywhere, and then you basically just do it a la carte. So I can do that. I can basically come in here and say, okay, I'm going to turn that off now. And I'm just going to leave it for this request. And it will basically log that request to the console. And then let's get a little bit interesting. We already did this one, so I'm just going to comment it out here. But let's do these ones. Here, I can choose a return format. And this was also very important for us. We wanted productivity. All these other libraries basically have to define a schema and all this stuff. And we try to make it easier for you. You can get very complex, but we want to introduce it little by little. I can get all the information out of this from the LLM. Not only a single message, give me all the messages that come back. I can get the raw response right here. So this basically is going to give me the response in raw format, and you'll see that from Open Router. And then here is also a very interesting thing. I can say, hey, AI chat, give me the top 3 features of callbacks in JSON format. And I can say return format JSON. So now I can produce or shape my result as I see fit. So let's go here and run BoxLang, samples, O3, and it's going to start running. I'll start producing the results, and once they come back, we'll show them. Okay. But you can see here, just a review for this example, you can have a return format, okay, which can have different values, and all of this is in the docs, of course. You can get all the data coming back, all the messages, the raw data coming back, and then in specific JSON format. All right, let's look at here. Woo, lots of stuff. Let's see here. Here is getting all response data. You can see that it basically produced an array of messages that came back from the LLM. Then we get back into raw. So this is the raw response. So you can see the ID of the request, the provider, the model, the object, when it was created, your different choices, etc. So this is basically now interacting with the model raw. And then at the end, we can see here, it basically says, hey, I want the top 3 features, and there's the JSON. Top 3 features, and there's the JSON. Boom, boom, boom. Okay. So very easily now I've created the ability to get different types of responses from my large language model. All right, let's get a little bit funkier here. Let's get more specific on the information that we get, because we're going to be building a solution here. So this is what's referred to as structured output. And this is something that we really wanted to add into BoxLang, where basically I can request the LLM to return data for me, and we've created a new BIF called AI Populate. And if you guys are familiar with Callbox, we have the ability to populate objects super easily in Callbox for ORM, for different types of stuff that we do with objects. And we did the same with AI. So now you have even an AI populate utility function here, which allows you to populate classes from AI responses. So here it is. Here's my prompt. I have a product description that says extract the product info from the following text and return only valid JSON. Let me leave it running so that way it's faster. And then I'll do the example. BoxLang examples 04. All right, leave that running. So I basically say, here is the whole description. Maybe this is augmented. Maybe this is coming from a vector database. And I can say, hey, chat, here's the messages, but I want you to do the return format to be this object. So you can see now that under models, I have a new product class. And here's my product. I just have a class with a title, price, category, in stock, and even features that it's an array. So it'll actually populate complexity for you and strong typing if you needed to. So that's what it does. And it says, hey, here's my extracted product. And there you go, right? So here we go. And here's the extracted product right here. So very, very easily, you can use structured output, give it a specific BoxLang class or even a CFC here if you wanted to. And then it's going to use our AI populate BIF and take that information from the large language model and populate your classes, okay? So it'll automatically create a schema for you. Now, this is a very easy way to populate classes. Now, if you have very convoluted schemas, you can use population with schemas. And that's in the docs, and that's more of an advanced topic. I'm not going to go through it. All right. Let me go next. Chat with different types of messages, right? So I'm going to leave this gun running as well. This way it's a little bit faster when I show the responses. So we'll go for 05 and we'll chat. And what this will do is that we have the capability now. We're introducing a new BIF. The new BIF is now called AI message. And this allows you to fluently create a message conversation that you can send to the large language model. So here I'm creating a system message. I say, hey, AI message, I want a system. Okay, and there's my system. And then it says, I'm showing you the system message. And then I can create a user message by just saying, AI message, here's a message. And you can even say message, get non-system messages, right? So there's all kinds of abilities for you to do if you wanted to get deep into the metadata. So here is where I can create a message also with a struct. So I can say, hey, create a message with a role and a content. Why is this important? Because the majority of the LLMs have different capabilities. So that means that this will work with OpenAI, but maybe it won't work with Gemini. So you can get very specific if you wanted to. You also can create an array of messages right here. So I can pass a whole array into AI message, and it's going to build them accordingly. And then I can send all those messages to AI. So here at the end, I say basically, here's my chat, send the entire array. Here you go. Or I can send the struct, or I can send the actual object. It's your choice. And of course, here it is. And there are all the different messages I sent. And there was my response. So You have a lot of capabilities here when building messages. We touched a little bit about multimodality. So let's look at the multimodality example. Okay, so we're going to do BoxLang examples 6. And in multimodality, what we do is that, let's say I want to work with images. And in this example, I can say, hey, AI. So they can say, I can start with an AI message. So I'm going to be fluent. And I'm going to say, what's in this image? And then I pipe it to an image method. And I pass the entire URL of this image. Here's another message that says, analyze this image in detail. And there's an image. And I can even pass the detail of the image. So I can say image, here it is, in high detail or auto detail or low detail. So auto is the default, low is faster, high is more detail. And then working with PDFs, I can say, hey, summarize this PDF document and pass in the URL of the PDF document. And then it's going to basically analyze that PDF. And then I can mix them. And I can say, compare these images and tell me the differences and pass 2 fluent images right there, image 1 and image 2. So you can chain and build this nice little message flux and send it into the LLM. And here's a real world image. Hopefully it didn't break. Let's see. Oh, there we go. Those are my dices. Here's a nice image. And this is where it says, AI message, system, you're an expert image analyst. User, describe what you see in this image and identify any text. And boom, I send that into AI chat. And there's my response. And here you go. A very detailed response, by the way. Overall scene, the image features a collection of 4 translucent dice, each a different color. So there you go. I have image recognition built in and 3 lines of code. And you can mix and match. So I can say, hey, here's an image, here's a PDF, combine them. Or you know what, attach this image to this other image, et cetera, et cetera. So multimodality, we really wanted to make it extremely easy for you to work with all kinds of things. Now, just to show you that there's all kinds of stuff with multimodality, I'm going to open the BIF here for AI message, not the BIF, sorry, the model for AI message. And by the way, just a little technical note and geeky note, the majority of BoxLang AI has been built with BoxLang. And here it is. Here's an AI message class. And you see that it has different methods. I can say embed audio. I can even embed a document. So I was using links before, but I can actually embed the binary into the request and it'll do it for any LLM. So if we look at the embeds, I can embed an image, embed audio, video, document, or PDF. Okay? So you have a lot of capabilities in BoxLang AI to work with multimodality. All right, we're getting deeper in the hole here. Multi-turn. What is multi-turn? Okay, let's run the multi-turn example. Sorry, examples 7. Multi-turn conversations. This means that we're going to be building a whole type of conversation list. So here you're going to have a message that starts with the system prompt, a user that says, what is a BIF in BoxLang, an assistant that describes what a BIF is, and then a user that says, give me an example of a common BIF. And then we chat. And then in this example, the conversation is going to be sent to the LLM. I'm going to get a response, and I'm going to use a nifty little BIF in BoxLang called CLI read to get input from the CLI. And I'm going to enter to continue the conversation. And you can see that I add to this conversation my response. And then I'm going to add another user prompt and says, how do I use that BIF in my code? And then it's going to send it to the chat, right? So right here, you'll see that when I ran it, it says, here's print hello BoxLang. This uses the built-in function. I'm going to press enter, and now it's going to continue the conversation and basically going to build that response and ask my follow-up question, right? So now I'm doing multi-turn, right? Obviously, I don't have memory here. I'm doing it kind of manually, right? But that's kind of how you start, right? If you want something very simple, right, there you go. And it created a bunch of examples here around the follow-up question. So multi-turn, very, very important. All right, little more funky, tooling. So let's look at tooling and let's leave this running. And we really wanted to make it extremely easy for developers to generate real-time tools. And this was thanks to our Jacob Beers developer, awesome dude on the Orchest team, who is in charge actually of the entire BoxLang IDE, by the way. So Jacob introduced the idea of tooling, and you do that with another BIF called AI tool. So with AI tool, you're basically going to describe what type of real-time tool you want to create. So here I'm saying, hey, I want to create a tool called Get Weather, which is going to have a description, get the current weather for a specific location. And then I just pass in a closure or a lambda. And in this case, I return a hard-coded information. But imagine I could be calling here a web service in order to get the current information for the specific location. In this case, I'm making it up. right? I'm just passing in the location and I'm giving it a specific weather, right? I even describe my parameters so the AI can get more information about what to do with it. And then when I go to chat, I basically say, hey, chat, here's the weather. What's the weather in Boston? Here are some tools for you. So now I've told the chat that here are some tools. And then when I call it, it basically says, here's the weather in Boston. Sunny, temperature 72, humidity, etc. And I even have a Celsius conversion at the bottom. So this is very, very important because I didn't show you the calculator tool just yet. So at the bottom, you'll see that there's a calculator tool. I also create another tool that basically just a very poor man's calculator. I also added Fahrenheit and Celsius to Fahrenheit. And then I basically describe those operations. And then I say to the AI chat, hey, use a calculator. But then I can combine them. And that's what happened at the end. It combined the weather tool with the calculator tool. And then whatever prompt I send, the LLM is smart enough, depending on my prompt, remember, of using those tools. And then it presented the results for me. It created the 72 degrees Fahrenheit, but it also converted it immediately to Celsius. So you can start to now get more funky with building your AI implementations. So those are chat tools. Let's look at chat streams. So this is just a simple one. I just wanted to show it. And basically you can create a chat stream. So you don't have to do a chat where you sit there and block and wait. You can actually do a nice effect where you're basically going to say, hey, whenever I start getting content, print that content, right? So here I say, tell me a medium joke about programming. And I say chat stream. So here's another BIF now. I'm using AI chat stream, and it's going to start streaming the response as soon as there is some data, right? So as soon as there is some data from the large language model, when it comes back as a server-side event, it's going to start streaming. Now, granted, remember, it's all about what model you're using, how fast it is, et cetera, et cetera, et cetera. But obviously, I haven't done a lot, but it's going to come eventually. Eventually, it's going to start streaming my response. I'm uploading a bunch of stuff, but we'll let it run. There you go. And now it's streaming the responses, and I'm outputting it to the buffer as I get all my responses. There you go. Took a little bit, but finally got there. Then you can get more funky, and you can even create nice UX. Remember how now all these tools basically say, hey, I'm thinking, or here is basically the reasoning. Well, all that information is available to you. And this is important. And this is where BoxLang AI shines. You see here that I have the chunking for the AI stream, AI chat stream, this chunk, and this chunk is a BoxLang AI chunk. And this means that it's normalized and it's documented. And that means that all the choices that come in into the delta, which is basically what's happening, is going to be normalized. So no matter if this is Claude or this is OpenAI or this is Gemini, you don't have to learn the event shapes. You're going to use just the BoxLang AI shape, and we normalize it. So here I can say, hey, I'm reasoning, I'm thinking right here, right, etc. So I'm not going to run it, but you can improve the UI as you see fit by using chat streams. Here's one with reasoning. Here's explaining what's happening. You can see that I even have a nice little thinking animation. Well, let's run that one because it's a little interesting. So in this case, it's going to say, explain why the sky is blue in one sentence. And you can see that now the request has been received and the server is already sending me information. So I'm basically saying, hey, I'm still thinking, I'm reasoning on what's going on. And I have that data. I could totally present it here. And then it basically streams the results. So you have all these capabilities. It's up to you how you build your UIs. All right. Message context, hugely important. Let's do a little bit of poor man's rag. So in this case, I want to be able to read some data that I have right here called customers. So basically I do here, hey, I'm going to load my customer database right here. And this is a very poor man's JSON customer database, which has 2 customers. And it also has, actually it has 3 customers. And it has a product knowledge. It has a little bit of information about products. So imagine if you're building a sales or a product chat support. Well, you have a database, and in this case, I loaded right here into my context. And then here's the prompt, and I want to look up a specific customer, right? And I say, hey, I want you to look up for this target customer Z001. So obviously, this is my poor man tool, and I can just say, hey, find me that customer. There's that customer. And then I create my message. So here's the interesting bits. I'm going to create an AI message. I'm going to say to the system, hey, you're an AI customer service agent. Use the customer data to personalize your response, customer context, and you can see that I even do, and let me introduce you to variables. So in AI, if you do the $ squiggly squiggly, those are considered context variables. And BoxLang AI can basically manipulate them at runtime. And here's another one. User, hi, I'm customer name. I need help with my recent order. Can you help? And then I can merge the context. So here's a format. Here's where I get some data. I'm going to create the message for the user, and I'm going to inject the customer, which is going to be replaced and merged into this context already, serialized for you in JSON format with the recent activity and the company policies for that specific product. And then I'm even going to do binding parameters. Okay, so you can merge context, which will basically go into the context, which is a special variable, or I can start binding different variables within my messaging. And then I've injected my data, as you can see, and then I just send that message to the chat. So now I've augmented my chat and I'm going to get a response. And I should have actually sent it so you could have seen it instead of you waiting for it now. But here it is. You can see that it loaded the 3 customers, right? It found John. So imagine if somebody was doing a request for John. And then there's my injected data that I'm injecting. And I'm augmenting my message and sending it to the LLM to figure out what John wants and what he needs to do with his support request. And there it is. It tells him, hey, John, hi, John. I can help with that. Here's a quick snapshot of your account. So it augmented it by giving real-time data of his account and then his most recent activity and then the information. So very, very easily, I've created a nice little sales augmentation here. All right, time to get more funky. AI chat can only get you so far. And we have about probably 10 minutes. So I have a lot more examples to show. I'm going to skip through a lot of them. I'm just going to go do 2 more. And I'm going to discuss what we do. We have the capability in BoxLang AI to create pipelines. And pipelines is basically the fluent ability for you to create code that can create a pipeline, a chain of execution, right? You have an input, I can put a step into the chain, another step into the chain, etc. In this case, I can have input from the user, I can create a message, I can direct it to a model, I can do transformations and get an output. So this is where simple chats are not needed. We're getting funky. So a basic pipeline could be something like, hey, I have a message here. Here's my system instructions. Pipe it to the default model and run it. That's it. That's a pipeline. Okay. Very, very easy. I can flow and read and exactly what it's doing. Okay. All the basics for pipelines are here, by the way. So if you guys want to read a little bit of what basic pipelines are in the docs and in the instructions. Okay? So a pipeline stream as well. So here I can say the same thing as did before, but using a stream approach. Okay. Here's transformations. Here's where we start getting really, really, really nice. So I'm going to run this guy. BoxLang examples number 15. And I'll let it run. And what do? Well, we have a prompt and it says generate a recipe for chocolate chip cookies in JSON format with ingredients, return only valid JSON. System, you're a culinary expert, return only valid JSON, no markdown, pipe it to the default model. And look at that. I have a built-in JSON extractor. So this is part of BoxLang AI. I can do as JSON, as XML, as Markdown, etc. And here I just did as JSON. So that means that the LLM will return JSON and it'll convert it for me and it'll deserialize it to BoxLang source code. Okay. And here I can just say, then when I get that data, send it to this transformer. So now I can actually get the response and send it to a transformer called recipe transformer. Models, recipe transformer. You can see that it extends the base transformer in BoxLang AI, has a single method called transform, and here's the input text. If it's a simple value, deserialize it. If not, use it. And then I'm going to augment what from the LLM, the instructions that come from the LLM to create all the sections that I want. And then you can even see that I have even a final tweak on that formatted recipe. And I'm going to basically add a fun header to the recipe. And then I run it. So when we look at this pipeline now, you'll see that here's the pipeline. It says, here's your delicious recipe for chocolate chip cookies. So this was the last transformation that I applied. And then it basically manipulated that JSON information and created a nice ingredients, instructions, etc. So that's the power of pipelines. Power of the pipelines is that you can take a prompt, you can pass it in to whatever model you want, extract it as you see fit, and transform it as you see fit. I can also do structure output. Remember we talked about structure output? Same deal. I can basically pass that class and it will map it to that specific class. I can also attach tools to pipelines. So here I have another example where I create different tools and I basically say here, hey, here's my message for my prompt. Here's the system. I want you to send this to a specific model, but hey, model, I'm going to bind you with specific tools. So there's all this language going on available to you to create this fluency. So I can say, hey, model, the default model, because I can change the model to Claude if I wanted to right here. There, now it's Claude. And I'm going to bind Claude with different tools that I created, and then it's going to be responding. So that's the power of pipelines. And then a multimodal one, it's a really funky one. So I'm going to run that one and end that section. So I'm going to go to number 18. And here is a multimodality, multiple models, very funky stuff. Here is where I have a message and it says, hey, I want you to write code to, and I have a binding variable. System, you're a helpful coding assistant that will write the code and return it only. Pipe it to the default model, and I can even give it a name. Okay, so now the LLM knows that I have a coder model. And then I say, hey, I want you to transform this code when it comes in. So that response is going to be transformed into a variable called code. And then I'm going to pipe it. I can use to or pipe as you see fit, to, and then I can basically pipe it and create a new thread and say, hey, iMessage, review the provided code. See, the binding is going to be available because I did this. Now, in the latest version of BoxLang AI, I can completely get rid of that guy and just say underscore input, and it'll do it by convention, okay? But if you want to do it explicit, you can also do it explicit. And then I'm going to say, hey, Claude, this coder guy created this code. Can you review it, please? And then you can see here, what are you going to review? Well, the task is this guy. So you can even have something that comes from a user and says, hey, here's a task for you to create. It'll create the code, and then it'll do a code review for it. And here it is. Here's the code, and here are the recommendations. So look at that. It created my sorting code, and then I added the recommendations. So very, very easily, you can pipe and create these complex situations very easily. All right, I'm going to end with agents because I'm already reaching on the hour here. So I'm going to start with a basic agent. And a basic agent, all it does is I use another BIF called AI agent. I give it a name, I give it a description, and I give it instructions, and that's it. I've created my first agent. Okay, I can put this in a specific scope. I can use it in Wirebox and attach it to Wirebox, right? I can have a first question. I can ask the user for more follow-up questions, and that's the whole point. It now has memory. There's a third question that it can handle, and then all the different configuration that I can show, and I can show the last 10 messages of the memory. So agents, in that case, are very nice because I can create them once, and I can use autonomy around it. That's one of them. Here one is another demo that you can run on your own, which is a more complex one. It actually creates a summary memory, okay? And it basically will create summarization on demand, and it creates a file memory as well. And it actually makes the agent now orchestrate with those two memories, okay? There's also tooling, another example here for tools. This one I'll show just because it's interesting. So let me show what it does. I basically created 3 tools. I have created a tool called Module List, which talks to BoxLang and says, hey, give me all the modules that are loaded in you. Module information, give me specific information about a module in BoxLang, and give me the BoxLang information from the server scope. Cool. And this is a new AI agent called Support Agent called Boxy, your BoxLang support agent. I give it some instructions. I tell it to do this, the default model, and I give it all the tools. And then I do a continuous loop. So here's where you would have a loop. Well, obviously, this is the CLI, right? This would be kind of like a standard IO loop, but you could do this at the web server level. But now I can basically say BoxLang examples. I'm going to run number 21. And now I'm in a loop. And it says, hey, ask the agent about BoxLang. Okay, what version of BoxLang is this, right? And now the agent is going to receive the request, right? I have a few commands here to show you later. But it's going to receive the request. And you can see that it's thinking. The tool calls have been detected. And there you go. It says running BoxLang version 1.10.1. It's giving me actual facts about me running in this application. And I can say what modules are installed. And now I'm basically telling it, hey, talk to BoxLang and find out, right, what modules do we have in our application. It's going to come back. You see that it's trying to put together all that information for me. And then it's going to present a nice response. And it says BXAI. I only have one module installed. Okay. All right. Great. Right. I can do history right here, and it'll show you all the memory, okay, that's available to me, right? I can even clear. Right here is configured with instructions, with the description, with the different memories. It can even show you a snapshot of what's inside of those memories, right? My models, shoo, and that's it, right? So lots of cool stuff that you can do. All right. Last one, agent scheduler. Let's look at that one. The agent scheduler is basically a class that is a BoxLang class, and you have a configure, and I create an agent called a support ticket analyzer. I have a database of tickets, and all it does is going to analyze those tickets all the time. That's all it's going to do. It's going to be analyzing tickets and tickets and tickets as long as it runs. Now, in this case, I had it every day at 9 a.m., but we can put it for every 15 seconds, right? I can do BoxLang schedule the examples number 23, agent scheduler. So right now, it's going to use the BoxLang scheduling for the scheduled task, and it's going to basically create and sample those tickets and analyze randomly those tickets. So you can see here that it starts and it says my scheduler has started. So I don't need cron. I can put this in a Docker container and I have scheduled task. I can put this in Lambdas, etc. And here it is. It's running a scheduled task. It's analyzing my support tickets, and there it analyzed my support ticket. I could send an email after this, right? You can see here that's my AI analysis, right? Priority high, the summary, website has been down, the suggested action, etc. So just like that, very easily, I can create a scheduler in BoxLang, create an agent, and schedule a task that every day at 9 a.m., it's going to analyze my tickets and send me an email. Okay. Or it can do it every period as you see fit. All right. Lots of goodies. I went through a lot of stuff here. There's more there. Trust me. But we're out of time here. I wish I could do another session with you guys, but I'll just open up a little bit to question and answers. But if not, we can move on. But I'm pretty sure that we're going to do another webinar because there's still so much to show you guys. And remember, BoxLang AI intro is where you're going to get all the information, and AI.orch's books is where you're going to find the docs. Okay. So I'm going to close my share here. I'm going to move a little bit to just question and answer, and then we can call it a day. Great question. If it tries to populate an object or a class, right, and the LLM hallucinates, obviously it's going to fail, right? I think you're going to basically get a response that says, "Hey, we couldn't populate." Right? So I think that would be a normal thing that would happen if you're making a request to a specific API endpoint and you don't set the information. You're asking about agent skills, but I think that in this situation, I think we're talking more maybe about agentic coding, which skills are used to basically augment, or are you talking about other things? Because that could be a plethora of things. In BoxLang, for example, agents can have tools, which basically are kind of like skills. Yeah, agent skills, in all honesty, are basically just tooling. It's exactly how you describe your tool and the way to do it, right? So it's really a discrete name capability that your agent has. A tool is basically your skill. Now, remember, a majority of these LLMs treat agent skills very differently. Not all of them are the same. There's also the concept of skills to create context as well. So, and that's actually a project that we're working on called in the Coldbox CLI, that it will allow you to create guidelines and skills. But those are basically to augment your context on the task at hand. So, like I said, different questions there. So the orchestration happens in the JVM. So BoxLang AI is your orchestrator. The models are just being called, and then BoxLang AI basically does the orchestration for you. All right, well, hopefully this was a nice introduction. Like I said, there's all these examples. I'm not even done with those examples. There's more stuff to see there and more stuff that I'm going to be adding to those examples. Please go to ai.boxlang.io. We'll publish also our keynote presentation as well. Maria Jose is going to be publishing that as well soon in our website. And of course, if you have questions, you can reach us in Slack or in our community in community.orchestrations.com. And any type of question, anything we can do to assist you, please let me know and we'll gladly help out. All right. Thank you.